Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss one of the topic from chemical bonding, that is isostructural species. Isostructural. So what is meant by isostructural? Iso means same. Here iso means same. The species which have same structure or same geometry or same shape, those are called isostructural species. The compounds are the species which have same structure or same geometry or same shape. Those are called isostructural species. Take some example. Example 1. Carbonate ion, nitrate ion, NO3 negative charge, and sulfide trioxide. I have taken 3 species. We have to find out the geometry of these species. Here, what is the central atom in carbonate ion? CO3, 2 negative. The central atom is, what is the central atom? Carbon. That means it belongs to 4th A group. And it contains 4 valence electrons. Now, 2 negative charge indicates that it has 2 extra electrons. Now, carbon is attached to 3 oxygen atoms. That means each oxygen can form a double bond. Now, bond pairs. How many bond pairs are there? 1, 2, 3. 3 bond pairs. Lone pairs 0. If any molecule has 3 bond pairs and 0 lone pair, already you know that the geometry is trigonal planar. Okay. Next, nitrate ion, NO3 negative charge. Here, what is the central atom? Negative. Nitrogen is the central atom. This nitrogen belongs to 5th A group element. Nitrogen belongs to 5th A group element. That means it contains 5 valence electrons. And along with 5 valence electrons, 1 negative charge. That means it has one more extra electron. One more electron is present. That means now 6 valence electrons are there. Now nitrogen attached to 3 oxygen atoms. That means it is attaching 3 oxygen atoms, and each oxygen can form a double bond. Now how many double bonds? 1, 2, 3. 3 double bonds. That means bond pairs 3. Lone pairs 0. If any molecule has 3 bond pairs and 0 lone pairs, the geometry is same, trigonal planar. Now sulfur trioxide. In sulfur dioxide, the central atom is sulfur. It belongs to 6A group element. It contains 6 valence electrons. And sulfur is attached to 3 oxygen atoms, and each oxygen can form a double bond. Now bond pairs. How many bond pairs? 3 double bonds. That means 3 bond pairs. Lone pairs 0. Same. If any molecule has 3 bond pairs and 0 lone pairs, the geometry is trigonal planar. Now carbonate ion, the geometry is trigonal planar, and nitrate ion, the geometry is trigonal planar. Sulfur trioxide, the geometry is trigonal planar. These 3 species have same geometry and same shape. Now, can we say these are isostructural? Yes, we can say that these are isostructural because these 3 species have same geometry, same structure. That's why these are called isostructural species. Now, see next example. Now I have taken 4 species CCl4 NH4 positive charge, BF4 negative charge, PCl4 positive charge. Now we have to find out the geometry of these species. In CCl4, the central atom is carbon. It belongs to 4th A group element. Now it contains 4 valence electrons. Now carbon is forming 4 bonds with 4 chlorine atoms. Carbon is forming 4 bonds with 4 chlorine atoms. Now bond pairs. How many bond pairs? 4. Lone pairs 0. If any molecule has 4 bond pairs and 0 lone pair, the geometry should be tetrahedral. Tetrahedral. Now see, NH4 positive charge. The central atom is nitrogen. It belongs to 5th A group element. It contains 5 valence electrons and 1 positive charge present. That means it indicates it has 1 electron is less. 5 minus 1, 4 valence electrons. It contains 4 valence electrons. Now nitrogen is forming 4 bonds with 4 hydrogen atoms. Bond pairs 4, lone pair 0. If any molecule has 4 bond pairs and 0 lone pairs, the geometry is tetrahedral. Tetrahedral geometry. Now BF4 negative charge. In BF4 negative charge, central atom is boron. It belongs to 3rd A group element and it contains 3 valence electrons and 1 negative charge. It indicates 1 extra electron. It has 1 more electron. Now boron is forming 4 bonds with 4 fluorine atoms. Now see bond pairs. How many bond pairs? 4 bond pairs. Lone pair 0. If any molecule has 4 bond pairs and 0 lone pairs, the structure is tetrahedral. Tetrahedral. Now PCl4 positive charge. In PCl4 positive charge, the central atom is phosphorus. It belongs to 5th A group element. It belongs to 5th A group element. It contains 5 valence electrons and it contains 1 positive charge. That means 1 electron is less. 5 minus 1, 4. 4. And phosphorus is forming 4 bonds with 4 chlorine atoms. Now we see bond pairs 4, lone pairs 0. And the structure is tetrahedral. Now these 4 species have same geometry, tetrahedral. Now can we say all these are isostructural? Can we say all these are isostructural? Yes, we can say that all these are isostructural because of all these species have same geometry, have same structure. That's why these are called isostructural species. Now you see conversions. I have taken 3 examples. 3 conversions. I have taken 3 conversions. Now we have to find out, is there any change in hybridization or not? We have to check. Now we have to find out the hybridization of NH3. Here the central atom is nitrogen. It belongs to 5th A group element. It contains 5 valence electrons. Now nitrogen is forming 3 bonds with 3 hydrogen atoms. Now 2 electrons exist as 1 lone pair. Now bond pairs 1, 2, 3, lone pair 1. Now steric number. What is the steric number? 3 plus 1 equal to 4. And if any molecule has a steric number 4, the structure should be sp3 hybridization. The structure should be sp3 hybridization. Now NH4 positive charge. In this ion, the central atom is nitrogen. It belongs to 5th A group element. It contains 5 valence electrons. But here 1 positive charge is there. That means 1 electron is less. 5 minus 1, 4. 1, 2, 3, 4. And nitrogen is forming 4 bonds with 4 hydrogens, and bond pairs 4, and lone pairs 0, and the steric number 4. If any molecule has steric number 4, the hybridization should be sp3 hybridization. Here the hybridization of NH for positive charge is sp3. Now in this conversion there is no change in hybridization. NH3 has sp3 hybridization, NH for positive charge has sp3 hybridization. There is no change in hybridization. Now BF3 converts into BF for negative charge. Now find the hybridization of this boron trichloride. In this boron trichloride, the central atom is boron. It belongs to third A group element. That means it contains 3 valence electrons, and boron is forming 3 bonds with 3 fluorine atoms. Now bond pairs 3, lone pair 0, steric number 3, 3 plus 0 3. If any molecule has steric number 3, the hybridization should be sp2. Now the hybridization of boron trichloride is sp2. Now we have to find out the hybridization of BF for negative charge. The central atom is boron. It belongs to third A group element. That means it contains 3 valence electrons, and here 1 negative charge is present. That means it has 1 more electron. Now boron is forming 4 bonds with 4 fluorine atoms. Now bond pairs. How many bond pairs? 4 bond pairs. Lone pair 0. Steric number 4. Hybridization should be sp3. Here the hybridization of BF for negative charge is sp3. In this conversion, hybridization changes from sp2 to sp3. Now H2O. In this H2O, the central atom is oxygen, and it belongs to 6th A group element. It contains 6 valence electrons, and oxygen is forming 2 bonds with 2 hydrogen atoms, and remaining 4 electrons exist as 2 lone pairs. Now bond pairs 2, lone pairs 2, and steric number 4, and hybridization should be sp3. The hybridization of H2 is sp3. Now H3O plus. In this central atom is oxygen. It belongs to 6th A group, and it contains 6 valence electrons, and it has 1 positive charge. That means it contains 1 electron is less. 6 minus 1, 5. 1, 2, 3, 4, 5. So oxygen is forming 3 bonds with 3 hydrogen atoms, and remaining 2 electrons exist as 1 lone pair. Bond pairs 3, lone pair 1. Steric number 4. Hybridization should be sp3. Here also the hybridization should be sp3. In this conversion there is no change in hybridization. In this way we can find out hybridization in the conversions. I hope that you understood this concept. Thanks to all for watching my video.